So this is the end of section 3. We kind of stopped in the middle and then took a quiz. I'll pass those back at the end of class. We're going to talk about solving these quadratics. We have been graphing them. We have been talking about their graphs. We've been finding the max, the min, the y-intercept, and actually putting them on a coordinate plane. Now we're actually going to talk about what happens when we are solving for them. The quadratic equation is a polynomial equation of degree 2. That means your x is taken to the second power. Degree 2 just means your highest exponent on your polynomial. All right, x is not equal to 0. If x was 0, then you would have a linear equation because you would not have a degree of 2. The factors of the quadratic polynomial can be used to solve the related quadratic equation. Solving quadratic equations by factoring is an application of the zero product property. So, you should have done this in like Algebra 1 and Algebra 2. Yeah. You factor something, set each factor equal to 0, and solve. You're basically unfoiling, all right? The reason you can do this is because we know from way back when that anytime you multiply something by 0, you get 0. So the very first step when we're solving by factoring is that it must be equal to 0, okay? So the first thing you have to look for is that it is equal to 0. Must equal 0. All right? Then you're going to factor. So what do I mean by factoring? Unfoil. Once it's equal to 0, you're going to look for the factors of the last that add up to the middle. Remember, if there's a first term, you have to multiply across and factor by grouping, but you have to unfoil it. So I'm going to look at this. Factors of 12 that multiply to give you positive 12 and add to give you negative 8.
6 and 2.
Right, so 6 and 2, and they both have to be negative, right? And so I'm going to say x minus 6, x minus 2, all right, equals 0. That's my factoring. All right, once I have that, it's really simple. Set each factor equal to 0. X minus 6 equals 0, x minus 2 equals 0, so x is going to equal 6 or 2. You can check this. You can plug in a 6. You can plug in a 2. It should make a true statement. You should get 0. Factors of 21 that add up to give you 10. What are they?
7 and 3.
Yep, x minus 7, x minus 3. When you set those equal to 0, you should get x equals 7 or 3. Completing the square. I will say this is typically the least favorite of all these solving types, is completing the square, right? Basically what you're doing is you're forcing a perfect square trinomial so that you can square root it to solve. Typically these are done when you have something that's not going to factor, right? So your first way, you're going to look and say, can I factor it? Is it possible to factor? If I can factor it, I am always going to factor. Then if you can't, there's two other methods really. It's completing the square and the quadratic formula. My go-to is the quadratic formula, just because I prefer it. Completing the square is it works well when you have like a square root that you can do really easily here. I will say that they give you this formula, and then when we do it, it's going to make a little bit more sense. What you want with these is you want to make sure you don't have a constant on the left-hand side. It's just going to get in your way. So you want to just have an x squared and a plus bx, ax squared plus bx, really. And you really don't want a coefficient on your x squared either, or do a different method because it's harder if you have a coefficient. You're going to complete the square by taking that b, that middle term here, and cutting it in half and squaring it. All right? And that is going to always equal x plus that b over 2 quantity squared. And so this helps you then solve for it. So it'll make more sense when we actually do one. Let's look at example 5. We have x squared minus 4x plus 1. There are no factors of 1 that add up to 4. We have a problem. We can't factor, right? And so this is a situation where you can complete the square. You have a rather easy middle term to cut in half. It's not hard. And then you can just do a square root, plus or minus, all right? So you do want this x squared minus 4x by itself. So the first thing I'm going to do is I'm going to subtract that 1 over. So I'm going to have x squared minus 4x, And that equals -1. All right? And now I can complete my square. The way I complete my square is I take this -4 and I cut it in half. All right? So -4 over 2, which equals what? -2. All right? And then I am going to square that, which gives me what? +4. And so I'm going to take that 4 and I'm going to add it to both sides. All right? So whatever I found there, I am going to add that to both sides. So the first thing you want to do is get your ax squared plus bx by itself. All right? Then you want to take your b over 2 and square it and add it to both sides. All right? And so at this point, I have an equation looks like this. I have x squared minus 4x plus 4 equals 3. All right? That's all I have. Now this left side here is a perfect square trinomial. This is a perfect square. The factoring of this will always be x minus whatever I had right here in parentheses, or x plus whatever I have in parentheses. In this case, I'm -2. So it's always going to be that number that I found when I cut my b in half. Quantity squared. That's how I would factor it. It would be x minus 2, x minus 2. Because you just created a perfect square. You forced it. And the right-hand side is just a 3. All right? Now to solve for this, I need to get rid of my square. How do I get rid of a square?
Square root.
Right. So I'm going to take the square root of both sides here. When I square root a square, I just have what's inside, right? When I take the square root of any number and a variable is involved, I have to consider the positive and negative root. Okay? Positive and negative root. So once I do this, my next step here is to factor it and then square root. Now my final step here is to solve for x. How do I solve for x? Yeah, add my 2 over. So I'm going to add my 2 to both sides. So x is going to equal 2 plus or minus the square root of 3. That's my answer. This is why you can't solve by factoring. Because, I mean, yeah, 2 plus or minus the square root of 3 is not going to be something you can factor, right? So once you get it here, add your 16s. At this point, you're basically factoring. This is a perfect square. You forced it to be a perfect square by doing what you did. The middle term squared means it's a perfect square. So that means this factoring will always be x and then whatever this was, +4, so x plus 4 squared. That's what this is if you factor it. If I were to factor it just like we did, you would get x plus 4, factors of 16 that add up to 8. So I just wrote it as a square, x plus 4 squared.
Okay.
And so once I have this set up, I just take the square root of both sides. The square root of a square is just what's inside.
What is 16?
The square root of 36 is positive or negative 6.
So
Quadratic formula. Quadratic formula, you are solving for x. So here's the biggest mistake people make on the quadratic formula. They put the x's in there. You're only using numbers. You're using A, B, and C. Those are the coefficients in front of your x squared, your x, and then your constant. Okay? So it is just the numbers. You don't put x's in there. You are solving for x. X equals negative b plus or minus the square root of b squared minus 4ac. All of that is over 2a. All right? So how do I use it? Well, first of all, just like in factoring, it has to be equal to 0. So for completing the square, it doesn't have to be equal to 0, but for the other two, factoring and quadratic formula, it has to be equal to 0. If it's not, you need to move everything over to the left so that it is equal to 0. All right, and then you are literally using the coefficients. So we're going to use our A, which in this case is a 1, our B, which is a negative 4, and our C, which is a positive 15. And we are simply going to plug those into the quadratic formula. So negative B, all right? This is A, this is B, this is C. Plus or minus the square root of B squared, negative 4 squared, minus 4 times A times C, all over 2 times A. All right, this is just simplifying at this point. I mean, it's basic, just order of operations. All right, negative 4, that's 4. Plus or minus square root, negative 4 squared is 16. Minus 4 times 15 is what? All right, all over 2 times 1, which is 2. Again, we're going to simplify it. Leave the 4 plus or minus 16 minus 60 rather is what?
Negative 44.
Negative 44 all over 2. All right, because we have done negative square roots, right? We have done imaginary numbers. We can simplify this. First of all, what can come out of the root? So if I do 44, right, that's 2 and 22, 2 and 11. That means a 2 can come out of my root, right? It's 4 times 11. 4 has a square root. So I have 4 plus or minus. A 2 can come out, and that negative can come out. How do I take a negative out of a root? What do I represent it with? I. And then inside the root is what could not come out, right? If it has a date, it can go out. If it's single, it stays in. 11 stays in over 2. You are going to simplify these just like you did your imaginary numbers, okay? So I'm going to say 4 over 2 plus or minus 2i squared of 11, helps to write that correctly, over 2. And then if I can simplify it, I will. And in this case, I can. 4 over 2 will simplify to 2. 2 over 2 simplifies to 1. So 2 plus or minus I square root of 11. That is my answer.